Okay, this is just to kind of finish up where we left off last time, because apparently I did not realize that this recording device, this camera, only records in 20-minute intervals. So anyway, there are really only, I guess, 3 things left that I didn't really cover last time that I added here and tried to record without realizing that it wasn't actually recording. So anyway, for item number, item number 11, right? You're going to also note that for each element A in the set of real numbers, there exists an element A inverse, that's how you read A to the negative 1, is A inverse, which is also written as 1 over A in the set of real numbers, such that A times 1 over A is equal to 1, which is also equal to 1 over A times A because of the commutative property of multiplication. This is referred to as the multiplicative inverse. And this is really a key idea because this is showing specifically that any number A divided by itself is actually 1, okay? Or if you think about fractions, if you're multiplying a fraction times its reciprocal, that will also be 1, okay? And that's a key idea that you really want to keep in mind, because a lot of students, whenever I work as a tutor, but a lot of students will have a kind of issue when it comes to things like choosing a special form of 1, and in a lot of cases that special form of 1 will just be a number over itself, okay? So that's a really key idea that you want to keep in mind. Item number 12, right, states that A times B plus C is equal to A times B plus A times C, and A plus B times C is equal to AC plus BC, okay? This is referred to as the distributive property, and this is really a key property among the field axioms of R because it actually shows that multiplication distributes across addition, okay? So it connects the two operations of multiplication and division. And again, this property, and all of these properties specifically, come from the fact that R, the real numbers, is what in abstract algebra is known as a field, okay? And a field has with it certain properties, namely these, that there exists an additive and a multiplicative identity, okay? That the operations of the field, the two operations of the field, are both commutative, okay? That there exist inverses for both of the operations, right? And that both of the operations are also associative and closed in that field, okay? So, those are some of the key foundational ideas of mathematics, really dealing with sets and with the field operations, or field axioms rather, of the real numbers. And from these, most of the other properties that we're going to study follow. So I will join you next time.